Okay, so question 55, which species in each pair is more stable? Again, this is just coming down to resonance. So can you actually form a resonance form? Can you do resonance for a negative charge or a positive charge? That's basically it. So the more resonance forms you can form, the more that species is going to be stable, or the more stable that species is going to be. Okay, so for sub-question C, we have a negative charge, and it looks like they're trying to tempt you into pushing it onto this carbon-carbon bond. So you can draw the breakage of that other carbon-oxygen bond. But remember, we can't skip over sp3 carbons. So if we try to do this, we'd end up forming a carbon with 1, 2, 3, 4, 5 bonds, and that would break the octet rule, so that's right out. So you can't do that. And if you compare and contrast to the molecule on the right, you can actually draw a resonance form. There are no sp3 carbons to skip over, and this is totally valid. So you could draw a resonance form, and it would look like this. 1, 2, 3, 4, double bond there, and single bond to the oxygen, and you have a negative there, so you must have no other positives in this case because our original molecule was negative. Okay, so we have a resonance form for the one on the right, no resonance form for the one on the left. So overall, the molecule on the right is more stable. Okay, and so then sub-question D, you have basically the same 5-membered ring with a nitrogen. The only difference is that you have 2 carbonyls versus only 1 carbonyl. So for the first molecule on the left, you can actually do a resonance form going up. You can do like this. And you can do the same thing for this molecule on the right. So you can draw resonance forms for both. And I'm not going to draw them out, but you can draw a resonance form for the one on the left and the one on the right. But the difference here is that you can actually draw a second resonance form for the one on the left. Okay, and again, I would never draw both of these arrows going simultaneously on an exam. This is just to show you that you can go one way and you can go the other. So you have this yellow possibility and you have the white possibility. If you were to draw, or if I was to ask you to draw both, you could draw one molecule and then you would have to draw it again up here. And instead of drawing, the first set of arrows, you could draw the second set of arrows going the other way, like this. And then you would draw the resonance form for both of these guys. And again, it would look very similar to what we've been doing in the past. So you have the nitrogen, double bond, single bond to oxygen, and still have a lone pair, and you're going to have not a positive, 5, 4, 3, 2, 1, 0. You're going to have a negative charge up here, and this nitrogen is neutral. And then the other resonance form is going to look like this, where you have the 5-membered ring, and it's going to be, basically the exact same thing, where you have the nitrogen right here, and you have double bond to this carbon and oxygen with the negative charge, and the other oxygen still has a neutral on it. Okay, so 2 resonance forms for the molecule on the left, 1 resonance form for the molecule on the right, and overall that means that this molecule on the left is going to be more stable. Okay, simple as that.